Hello and welcome to this developer tutorial. Today we're going to be speaking about the Magic Leap 1 control. This is an electromagnetic 6-DOF controller which handles position and rotational information. It also has various inputs such as the trigger here, a bumper, a 2D touchpad and a home and back button. The 2D touchpad also has force sensitivity and radial and swipe gestures inbuilt into the API, which you can access via Unity. It also has inbuilt haptic feedback. So today in Unity, we're going to show you how to shoot a ray beam from the controller out towards our mesh or a digital object. We're going to be able to place down a digital object using the bumper and pick it up and manipulate that object using the trackpad. So let's get started straight into Unity. So let's get started with pulling in a controller prefab, pre-made in the SDK. Search control in the project window and you'll see this one control here, which is a pre-made prefab with everything we need. The other one is the rig and the FBX model. So this is the one we need, full with the controller input handler, the control transform, everything hooked up. So as soon as we pull it in and if we press play, we would see it in the editor. There we go. So, what do we want to do first? We want to create a dynamic beam shooting from the controller so that we can see where we're actually pointing it in relation to the world. And we actually want it to interact with the mesh around. So let's start a script and call it dynamic beam and open up in our IDE. I'm using Visual Studio. And let's first include the Magic Leap XR API, so Unity engine.xr.magicleap, public game object controller, and then we'll bring in a line renderer and call it beamline. Next, in update, we'll make sure we're setting the position, transform position to the controller position, and the same with the rotation. So now we're going to do a raycast. We're doing raycast hits, and if physics raycast, we're shooting from the position of the controller outwards in the forward vector, and we're saying beamline is using the world space, and then we're setting position 0, which is the closest to the controller, to be transform position, and setting beamline 1, which is the very end of the beam, to exactly where the hit point is. If it isn't raycasting, else disable world space and point our beam forward, say 5 units, 5 meters technically. Unity units, 1 equals 1 meter. In our start, we'll make sure we've got beamline, adding a line render component, and we can also set the color, start color to be green and say the end color to be red just for now, and then we can view it. We'll create a public function instead, so we'll have a public color, start color, and a public end color, and replace those two so that we can actually edit them from the editor instead. Let's come back to Unity and add in a line renderer on our game object. Obviously it's too big, so let's move that down to say 0.01, and let's also make sure that we're setting default line as the material there. And we're already editing the color in our scripts that we've previously assigned. So once that script loads in, we can pull in our controller and we can grab our color, our start color, we can say blue, and the end color, let's say a nice pink or so. That looks good. So at the very start of the controller, when we press play, we'll see it's blue and it fades all the way down to pink. Let's pull in a quick game object here, a cube, and we can see, because it's got a collider on, how the ray, the beam coming from the controller, will look like when it interacts with any physics object, anything with a control on. So the meshes in the Magic Leap that we create with our spatial mesher are all using mesh colliders, and it will behave in the exact same way. So when we launch Unity Remotes, we're demoing through the editor, it's going to build up the mesh, and exactly as we can see here, when the beam is pointed from the controller at any form of mesh, it dynamically changes its size to fit within those bounds. This is great when you're trying to understand the world around you and shows you really the power of spatial computing, even just via a simple mesh like that. Now that we have our dynamic beam, we actually want to place an object at the end of that beam when we're hitting a material. So let's create a new script and call it place object. And we'll open up our editor again, and we're going to create this script that places an object wherever we point our raycast and whenever we press the button on the controller. So again, let's include the Magic Leap SDK, the APIs, public game objects, object to place. Now this will be any object that you choose, and make sure that we're hooking in ML input controller and call it controller. In start, we'll enable input using mlinput.start, and we're having a listener function for onController button down, and it's listening for a method called onButtonDown. We're also going to use controller is mlinput, and we're getting the controller mlinput.hand.left. It can be right or left, it's just best to be consistent. Now we create this listener function called onButtonDown, and we're saying if button is the Magic Leap controller button.bumper, then we're going to do a raycast at this point. We're raycasting again from the controller, so from the controller position forward and wherever it hits. So as long as it's hitting a mesh, it will hit. And in here, we'll place the game objects. And we'll just instantiate the game object that we placed in the public game objects variable. We're going to place it at hit point and also the hit point rotation. Then we'll just create an onDestroy function, so when the application stops, it stops looking out for Magic Leap input, and it stops the listener function of onButtonDown. So as you can see, this is a really simple script. All it does is it gets the controller, it gets the button input, and raycasts from the controller to the hit point, wherever there's collision, and places your object. Now let's see that running. So let's look out for an object. This looks pretty cool. Spaceship. Let's put it into our scenes, give it a look. Pretty cool rocket. We'll add a box collider to this, and we'll probably scale it a bit as well. Cool, so let's now make it a prefab, and with the new prefab update in Unity 2018.3, we can now create prefab variants. And let me just rename this so we know which one it is. And then we can pull it into the place where we had our public variable for the object to place. And we can now get rid of it within our scene. Now let's press play, launch Unity Remote, and we'll be able to see it running in the editor. And what happens when we point our object, we press the bumper button, and we can place now the object on any mesh within our meshed area. Lovely. Now let's just scale this a bit more. Let's go to maybe 3 and set the origin to 0, 0, 0. And let's show you again in the device stream. So you can see now through the capture of my device, I can place it on my desk here. I really love showing device stream here as well as zero iteration with Magic Leap Remote, because it really just shows you how a developer can iterate so quickly with changes in the editor, press play, and you can view those changes again, either through the device or cast them to your screen. So let's quickly add a rigid body to this. Add component, rigid body. Now when I press play, because it's a very bumpy mesh, obviously I've got a lot of stuff on my desk and my sofa, we can see that the objects are just falling over because they have physics enabled. We can point the controller at the wall, at the sofa, at the floor, and the objects will spawn and fall with gravity. So we have object placement, we have our dynamic beam. Now we actually want to manipulate the object. So I want to be able to pick up the object at the end of my beam. I want to scale it and move it closer and further away. So let's create a new script and put this on our Magic Leap controller input, and let's call it manipulate object. As before, we're getting the controller with ML input controller. We're creating a game object called selected game object, the one that we're picking up. We're going to have an attach point, and we also have the controller object. Now in start, again, we're enabling magic leap input.start. We're getting the controller, ML input, get controller, magic leap hand left. Then we're going to add a trigger, a bool trigger, to say, yes, we can actually push the trigger. This is a value between 0 and 1. And then we're going to create a method called update trigger info. So when we pull the trigger, we're going to do something in this method. We'll do if statement if the controller.trigger value is greater than 0.8. So full trigger press is 1.0. Nothing pressed on the trigger is 0.0. We'll do if trigger is true. So are we allowed to pull the trigger? Yes. And we'll raycast from the controller as before when we push down the trigger. We're going to check if the object that we hit has a tag called interactable. If it's a mesh around our scene, if it's a spatial meshed object, it's not going to have that. Our objects that we can pick up will have an interactable tag on them. And then we'll say the object that we hit, if it has an interactable tag, it will become the selected game object. We're going to get the component, the rigid body component, and disable gravity because we don't want the gravity to have effect while we're picking up the object. And then we're going to take attach point and get the transform position and say the hit position is the attached position, so that we're attaching the game object to this attach point along our beam. Once we've done the trigger, we can set the trigger false, so it means that we are allowed to press the trigger again. And then when the trigger value is below 0.2, we have to reset the trigger. We're saying if the selected game object is not equal to null, so if it's actually got something in it and the trigger value is less than 0.2, we need to disable gravity, and then we need to disable the selected game object and set that to null. It means that we've let go of the trigger and that we've let go of the game object. In update, we again need to do the transform position and the transform rotation. This isn't exactly necessary because we've already got it in our previous script, but this script could go on a standalone. It doesn't have to be on the same game object as beam and the place object that we've done before. Then we have in our update, if we do have a selected game object still, we want to say that the position of the selected game object wants to stick to our attach point as well as the rotation. So we're always updating the game object to the attach point every single frame. And then we're going to call the update trigger function, which is checking our trigger to check if we've released it or if we've pressed the trigger down. Next up, we need to make sure that we're setting the interactable tag on our rocket. And we need to make sure this is the exact same with the capitalization as well. And then once we've created the tag, we also need to remember to always give the game object that tag. Actually, let's just make that vector3 variable, the attach point, a game object, so we can pull in the game object on the controller. So let's go back to our script, change vector3 to game object. And in our code, let's change it to attach point.transform position in both instances. Always fun live coding. Let's add a game object to our controller and call it attach point and just put it just a few inches off the controller, and we're pulling in this attach point into our script. Now we can see when we pick up our object with trigger, we can move it around. Gravity is disabled. We can pick it up and place it anywhere else on the mesh. The final thing I would like to do is to add to this manipulation script so that when we're picking things up, we can scale them and move them closer and further to you by pressing the touchpad. So let's add this method called update touchpad. We're going to get the controller.touch1 active. We need three variables. We need x, y, and a z, which is the force. So we need touch position and force of the X, touch position and force of Y, and then the force is the Z value. So we're going to say if the force is greater than 0, which is we're pressing down on the controller, if X is greater than 0.5 and less than minus 0.5, so this is a value between -1 and 1 on the touchpad axis, then we're saying selected game object.transform local scale and scale that by X and delta time. If we're pressing anything on the Y, we want to move the object, so move the position of the object up and down the beam. So we're doing attach point.transform.position equals vector3.move towards from the attach point and timesing that by Y and delta time again. So let's quickly scale the object, let's say 3 by 3 by 3, because it was still quite small last time, and make sure we're setting everything to 0. Let's press play and see how this runs. What we should see is, like before, we can place our objects, we can scale them with the X value on the touchpad, and we can move them closer and further away using the Y value on the touchpad. So just in these 18 minutes, we've created a dynamic beam, we've placed an object on top of a spatial mesh, and we've enabled object manipulation with the controller to scale and translate the objects around our space. Now it's really easy for you to be able to swap in different game objects either at runtime or in the editor by changing the prefab that we've selected to pull in your own assets. As before, please do check out the Creator Portal and the Unity tutorials to see all different tutorials, especially ones that consider raycasting and controller input. And as always, make sure that you give Magic Leap Devs a follow on Twitter and keep up with the community. Together, we can build the future.